Hi everyone, welcome to our video on the rules of differentiation, where we will be looking at the rules for our exponents. So to do derivatives that we will be doing very soon, it's important that we are able to put it in the function in the correct form. And it often involves making sure that we have the power written correctly. And so it goes back to our rules for exponents that were from like algebra classes. So it's been a while since we've seen them. We've been doing this one a whole lot, number 3. So multiplying the same bases, we just add the powers together. But let's go ahead. These two are super important to us. These ones with the dot are nice for really simplifying. So these 2 stars that we're going to use a whole lot. These other 4, it's good to know, but it's really just for slight simplifying stuff. Okay, anyway, so let's rewrite some of these expressions. So let's rewrite the expression using the exponent rules. So the square root of x, this is the one time in math where, let's rewrite it, I'm going to do it extra big. So this x does have a first power to it. The square root is actually one of the one times in math where something that isn't shown is a 2. So this becomes, so the 1 is the power, and then the 2 is the root, so we write that as the 1/2 power. So that's rewriting it. So this is going to be better for us when we start to do derivatives. Okay, so that's all there is to it. So most of them are pretty fast to rewrite. On number 2, we have 1 over 7. Now 1 over 7, that is just 1 over 7, like that. So the 7, so the regular old numbers just stay where they are. But this, the x to the 3/5 is how we're going to rewrite that. So we see the power is 3, so that goes in our numerator for the power. And the 5 is the root, so we write it as 3/5 like that. Now, what we'll need to do very soon is rewrite it one more time. I'm going to write just the 1/7 out front. And then we're going to use our second starred rule there for the negative powers. So I have it as 1 over xp, just like as we see it, so just a power. And we're just going to move it up top and make it negative. So I'm just going to put it to the side of this like that. And then let's just make the power negative. There we go. Okay, and this again is going to be better for us very soon. So it might not look better than what we have. Well, this doesn't look good either way. But this is going to be better for us very soon. Okay, and then our next one. Well, 5/7. So this one's actually easier than number 2. 5/7 is just out. I'm going to leave it as, so this is just the coefficient that would be hanging out front. X to the 3rd, well, I don't want it down in the denominator. I want it to the side. And this is the same thing, so I usually prefer to see it to the side, but this is the same thing like that. Okay, so I prefer this, but if you prefer that, do that. I mean, they are the same answer. Okay, so I just use the rule, the positive power in the denominator. I'm moving up and making it a negative power. All right, then we've got for number 4, well, this is we see the same bases being divided. So the 2 is just hanging out again. And then our rules for this is to take the 6 and subtract the 3. And so 6 minus 3 is 3. So it's 2x cubed. Again, notice the coefficient just always just kind of hanging out, doing its own thing. If you're ever confused about the rules, you can always, so the 2 is again just hanging out. You can always go back to what this really means. Remember that powers just tell you how many times you're multiplying it by itself. So I would have 6 x's like that getting multiplied, and then x cubed would be x times x times x. And then we could use our rules for dividing. So these would divide each other, and we could see, oh, there's x times x times x, which would be x cubed left over. Okay, so if you're ever stuck on it, you could always try to break down how they originally meant, but these shortcuts are useful for us to speed it along. Okay, and then in number 5, we've got multiplication. Well, in multiplication, you do multiply like parts. So the 2 times the 5, the constant parts would multiply, and that gives us just 10. And then the x's would multiply, and I have x. So this is where the powers would add. So typically, we would probably just write x to the 5th immediately. But I just wanted to show, hey, 2 and 3 would add, and it does give us x to the 5th like that. Okay, so that's that rule. And then one other, whenever you have, so this 3x to the 5th, to the fourth afterwards, this is when you have a power raised to a power. Now, it's kind of like distributing. So this is only multiplication. So with, let's make sure we know the difference. So with multiplication or division, this power, that 4, the outside power goes to all parts. So this is the same thing as 3 to the 4. So it's like the 4 is kind of like it's distributing. So it's 3 to the 4 and then x to the 5th to the 4, like that. And then we would simplify. So 3 to the 4, that is just going to be 81. With this, the 5 and the 4 would multiply. So think of it just like with this big parenthesis. That parenthesis, often parentheses means multiplication, and that's what it is in this case. So the 5 times the 4 do multiply, and that is x to the 20. So it is 81x to the 20. Okay, the other thing you could do, so depending on the power, so just to real quick, if it was 3x to the 5th to the 4, again, you could rewrite it if you're a little confused about the rule. Say you don't know whether to add or subtract or add or multiply the 5 and the 4. You could write it out like we did for number 4 there. The fourth power is saying do that like that, rewrites it expanded, and then from there you can see, well, 3 times 3 times 3 times 3 is still 81. And then now you can see, well, x to the 5th, I should add these powers as I go. So 5 plus 5 plus 5 plus 5 would be 20. Okay, so you could always get it. All right, be careful though with this. Let's add one other note. So with multiplication or division, we can just kind of distribute almost. If it was a plus or minus inside those parentheses, so if it's plus or minus, so if this was, I'm going to write it like this. If it's a plus b raised to some power, remember we would have to rewrite it. So this would be a little tough with that fourth power, but we would have to rewrite. So if it's an addition or subtraction, so add or subtract, we must expand. And then often we just say FOIL. So this would take a long time. The foiling must expand, and generally we just say FOIL. Okay, so remember, if it's a plus or minus, we have to rewrite it. Typically, the square is kind of the biggest power that we deal with it. But in case it is a higher power, you would have to do that. Okay, so that's a little rougher. Okay, anyway, so again, shortcut, if there's no plus minus, it's better. Plus minus, a little worse, a little extra time. Okay, so there's our quick rules. Okay, so we'll be using, again, these 2 starred ones a whole lot. The other ones are useful too, but that's it for now. So that's a quick review. In our next video, we'll start our derivatives. So thanks for watching, and I'll see you next time.